Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today we're going to continue along with Chapter 17 from the book Clean Code by Robert C. Martin. Chapter 17, we're talking about a reference list of smells and heuristics that you might potentially come across when you are doing your development, programming, coding, etc. And we did a part 1, and today we're just going to go through a part 2, probably am not going to be able to get through the entire chapter, so this will actually be our first 3-part video. With part 2, we are going to be picking up right after we left off at this feature envy smell/heuristic, and we're going to go to the next slide and pick up where we left off with the general category of smells and heuristics, starting off with selector arguments. So what Uncle Bob meant by this is that there are functions that you might come across that take in a Boolean variable where you select the behavior of the function depending on the Boolean. And in general, this is not a good idea to do. It's better to just extract the actions of that functions out into many other different functions. And it doesn't necessarily have to be a Boolean, but this is like the most common way to see it. So you pass in a Boolean argument to a function, and then inside that function you have conditional statements that check, okay, if the Boolean is true, we're going to do this. If it's false, we're going to do this. And it's just better to extract out those conditionals into just separate functions. Next, we have obscured intent. Obscured intent. This is where Uncle Bob says you need to make the intent of the code very, very visible. And sometimes when you compact things and you make them very small and all on one line, it makes it hard to read. And a perfect example of this is one that he uses in the book here, where you have like a run-on expression. So you have a very long mathematical calculation, and maybe sometimes it's better to perhaps split that up into multiple variables instead of having it just all on one line. Is not like it's not like a bad thing to do, but sometimes you have to kind of roll with the punches a little bit, and sometimes it's going to be okay, and other times you need to make the intent of your code visible and not obscure the intended action of your code or functions or what have you. Next up, misplaced responsibility. This is where this principle of least surprise comes in. So basically, code should be placed where a reader would naturally expect it to be. Placing code where a reader would expect it to be. So this is, for example, a constant. And maybe it makes sense for a constant to go in one class over another class. So you have like a pi constant, right? Because pi is 3.14, and then several other, goes on forever, right? Should that pi constant be in, an employee class, or should it be in the trigonometry class? Probably makes sense more to put it in the trigonometry class, just because from initial hearing the different options, employee, what does that really have to do with pi, trigonometry? You could kind of see, okay, maybe we're going to be calculating the, area of a circle, etc. Maybe it makes more sense to go in there. So placing it where a user would most likely, doesn't necessarily have to just be with constants. It can extend to, other things as well. Next up, an inappropriate static. So Uncle Bob says, when in doubt, make a function non-static. And when you're thinking about when you create functions, you got to think about if there's a chance for a function to behave polymorphically. If there is a chance for it to behave polymorphically, you might as well just make the function a part of that class. Now with static methods, yes, they are a part of the class, but they're not necessarily part of the object. Like what's a good way to explain this? Static methods, you only need to call the class dot static method. So you don't need to create an instance of the class to call the method. Well, this is fine, but it doesn't leave it open to polymorphism, so you can't implement those methods in your own fashion. So if you have a shape class, right, you could call shape dot, get area, right? Shape dot get area, but it might only get the area for like one specific shape, like a triangle. That's where then you might have to create conditions within that static method that checks, okay, are we looking at a triangles area? Are we looking at a circles area or a squares area? It'd be better in that situation to just create a square class, a triangle class, a circle class that extends shape and implements the get area method of shape. So that's kind of what he means by an inappropriate static. Static methods are fine, but when in doubt, you should just make functions non-static. Next up, use explanatory variables. So this is where you can break calculations up into intermediate variables. So for example, if you do have like a long calculation, so if you have a long calculation, right, maybe break it up, break half of it up and then assign it to a variable. Something as simple as, product value. Maybe you're like multiplying and adding in the same expression, right? Product value could be assigned to the multiplication part. And then the next half, sum value, could be assigned to the sum of the addition part, the total from that. And then you return, product plus sum, something like that. Or you can do, in the example they give in the book is of a matcher pattern. So you have your matcher function, you assigned it to match, and then you use the match in your conditional. So the match is kind of the explanatory variable. It explains what the function just did. It found a match. And then that, okay, the match is a Boolean value, so you can use it in the if conditional, et cetera, et cetera. So using explanatory variables as intermediate values to kind of bring more intent on what your code is doing. Functions names should say what they do. This is the next one, pretty self-explanatory. We've talked about this earlier on in the book. Use proper naming conventions. Name your functions, an appropriate name that shows what they do just by looking at the name of the function. You shouldn't have to read the function to exactly know what it's doing. The intent of the function should be within the name. Next up, understand the algorithm. So a function should be so clean that it is obvious at how it works. So this is something that's a muscle and that takes time. I know at my job, this is something that I have been trying to work on and really trying to write your functions cleanly and using the principles from this book so that it, again, going back to the last bullet point we just talked about, it makes the intent of your functions that much better so that it's obvious at how they work, because it helps with other people on your team when they go to potentially add things to your function or maybe refactor it a little bit or just using that function in other parts of the code that they understand and they know what it does. So understanding the algorithm. Next slide. Making logical dependencies physical. Making logical dependencies physical. So this is where you specifically ask another module for what you depend on and not make assumptions about it. So we shouldn't just hard code dependencies all over the place. Yes, sometimes that's good, but in a lot of other cases, if you do depend on something from another module, then call that module to get that dependency. So an example that they use in the book is with this page size constant, right? So instead of hard coding it in this hourly reporter class, they should go and get this page size from another class. Because maybe, and again, going back to one of the first bullet points that we talked about in the video about misplaced responsibility, maybe page size doesn't really go in the hourly formatter class. It really, using the principle of least surprise, it should come from another class. So instead of hard coding it, get it from the other class. Next up, polymorphism is preferred to the if-else or switch case. This basically means that you should open and close principle, right? If you guys remember, we talked about that. Classes should be open for extension but closed for modification. So use polymorphism to your advantage to create different classes and implement methods from those different classes rather than using if-else or switch case statements to call different methods. So you essentially, if you do create like a piece of code that has if-elses, you could potentially extract those if-elses, maybe into another function. Or think about this, each if-else could potentially generate a different class. So if you are checking for a triangle type, for a square type, for a circle type, and depending on what type it is, you're going to call that specific area function to get the area of that shape. Well, there's where you can extract that out into different classes. So polymorphism is preferred over that. Following standard conventions, this one's pretty self-explanatory. It's not that you're using anything that's right or wrong. It's more so if you're going to have a convention, make sure everybody on the team agrees with it and sticks with it. It doesn't necessarily have to agree with what every other team in your company or across the country does. But as long as everybody in the team agrees with the standard, then just go with that and make sure everybody follows it. Next one, replace magic numbers with named constants. Kind of self-explanatory. If you have any big numbers, pi, Planck's constant, the speed of light, stuff like that. Instead of hard coding the actual number pi, 3.14 ... you should put it within a named constant and then call that constant in places. Next up, be precise, especially with mathematical calculations, with rounding, with other mathematical functions, with database calls, with null checks. Be precise, says Uncle Bob, and don't get lazy with your precision, basically. And don't try to compromise by, having stuff be, approximate, etc. Because think about if you have like a banking app or something financial related, those rounding errors could potentially be, big deals. And this is something that I kind of struggle with. I'll be the first to admit, guys, that I sometimes, try to get things working as fast as I can, and I don't really think about things in a precise fashion. So be precise, says Uncle Bob. Next up, structure over convention. Naming conventions are great, but classes that are extended enforce compliance. So he basically says that structure is going to be the ultimate way to adhere your team to your standard operating procedures for your code. So yes, you could have conventions like, we're going to name all our classes this, or, we're going to name all our variables starting with this. But classes and polymorphism are going to enforce compliance. So when you extend classes, it's going to enforce the fact that you have to implement certain methods, especially with interfaces. When you create interfaces and you have to use those interfaces, it's going to enforce you to implement those methods in the specific fashion for your intended function. So that's kind of what it means here, structure over convention. Next up, encapsulating conditionals, extracting functions that explain the intent of the conditional. So basically, instead of having, a conditional check like does not equal or greater than or less than expressions within a conditional, within an if conditional, let's say, you should extract those out into functions that explain the intent of what you're checking. So instead of saying, oh, if x is greater than y, you should have if first digit greater than second. And that would be your function, right? And then within that function, you're returning if x is greater than y, and you're passing in two arguments there within that function, and it's going to return a true or a false. So encapsulate conditionals and extract them out into their own little functions. And then going along with that, avoid negative conditionals. So you're not using the not operator. And I don't know, I use the not operator a lot, but Uncle Bob brings up a good point. It's basically just the fact that sometimes negatives are just a bit harder to understand, so you should kind of avoid them if you can. Next up, functions should do one thing. This one's self-explanatory. Single responsibility principle, right, applies to classes as well. Next bullet point, hidden temporal couplings. Basically, be on the lookout for functions that need to be called in a certain order. The order in which things should be called should be obvious, so it doesn't confuse another developer when they try to create maybe another sort of algorithm within your project, and they're calling certain things out of order to achieve maybe like a calculate pay method, right, for employees, and you need to call other certain things in a certain order in order to get to the payment for an employee for the week. That should be obvious. And you should be careful that everybody knows the order in which to do things. And one way to do that is to produce something that the next function needs. So if you need to go and get the employee ID, assign that to a variable, because then you can have that employee ID be an argument to the next function, which is get employee hourly rate. But you need the employee ID to do that, versus, just calling, get employee ID, get employee rate, because then you could maybe get confused into, oh, does this need to be called before that, etc. So you guys see what I'm saying? Assign variables to functions and then use those variables in the next function calls and the next function, and then use that, assign another variable to that next function call, and that way the order in which you call things is very explicit. Don't be arbitrary. The reason you structure your code should be communicated by your code, and it will empower others to do the same. So if you are very, again, not obscuring the intent, and you're very deliberate, it's going to empower users to do the same thing in their code. And if you're not doing those things and you're very lackadaisical with the structure of your code, then it's going to cause potentially other members on your team to change things and do things their own way. But if you want to adhere to certain standards, don't be arbitrary. Next up, encapsulate boundary conditions, put them in a variable. So the boundary conditions, like the ending of lists is a boundary condition. The beginning of lists is maybe like a boundary condition to like one spectrum. And essentially what he's saying here is that, how we said encapsulate conditionals? Well, encapsulating boundary conditions could be, instead of saying, okay, So size plus one, right? Like the size of list plus one, or list.size plus one, you can assign that to a variable and then reference that variable as the boundary condition just to reduce confusion within your code. And then last one, guys, functions should descend only one level of abstraction, which is one level below the name of function. So basically, in one way to tell if you have multiple levels of abstraction within your function is just see the indents. See how deeply indented your function is, and that can sometimes tell you that you have multiple levels of abstraction. Now, what this isn't saying is, you can have multiple functions within your function. And yes, you have multiple levels of abstraction in your function, but they are abstracted out into other functions. What this is saying is within one function, it shouldn't descend to multiple levels. It shouldn't be all descended all inside that function. So when you break up a function, you can reveal other levels of abstraction you may have missed. And hopefully I'm explaining this one right. Check out the indents, but it's not even the indents, because there could be hidden abstractions that you don't really see within your function. So just remember that functions should descend only one level of abstraction to keep things a little bit cleaner and a little less confusing. Still break them up into other functions, but within one function, it shouldn't descend into multiple levels of abstraction. Hopefully that wasn't confusing. Lots of abstraction and function word usage there. But yeah, that's going to do it, guys. Kind of a shorter video again, and we'll have to finish with a part 3 next time because there's a lot of smells and heuristics in chapter 17. So we'll finish up part 3 next time. Let me know if you guys have any questions on these smells and heuristics. I can definitely go deeper into it. And thank you guys so much for listening. We'll be back with part 3 next time of chapter 17 of Clean Code. My name is Chris. This has been Chee-Tash. Take care.